Alright guys, so there should be your answers for D, E, and F there. So if you have problems with that, I would double check to make sure your calculator's in degree mode. Make sure that you put in the right trig ratio. And yeah, just to kind of start troubleshooting that there. Now what we're going to do is we're going to make it a little bit harder on you guys. So let's just kind of make up a scenario here. Let's kind of have some fun with this. So let's go. So we got student number 1. Normally I'd ask for volunteers, so I'm just going to volunteer. Let's go Leilani. So Leilani's laying on the ground, and let's go with Derek. And Derek is standing 3 feet away. Derek, I'm just going to guesstimate you're 6 feet tall, okay? So that kind of gives you an idea of what sort of situation you're going to be looking for. So let's use the same names here. So we got to look at 2 things when we're identifying word problems. We're still solving for the angle, but we either are going to be solving for something called an angle of elevation or an angle of depression. Okay, so big things with these, an angle of elevation is kind of when you're looking up. So you have a horizontal and you're looking up. Angle of depression is when you have a horizontal and you're looking down. Okay, so if we were to keep this going here, so we have Leilani is looking up, gazing longingly into Derek's eyes. Okay, so again guys, you know my artistic skills. So you got Leilani staring up at Derek, staring longingly at Derek. Okay. So what is the angle of elevation from Leilani, who's on the ground, to Derek, who's standing up? We're not necessarily going to solve this, but I want you guys to see what's going on. So, since it's an angle of elevation, we're going to have some sort of horizontal right here. Okay. And then angle of elevation looking up. Elevation up, up. Okay. So Leilani gazing longingly into Derek's eyes is what's gonna give us that angle of elevation looking up. Okay, so you can see that now an angle is formed between the ground, and that's gonna be our theta. And then we're going to have another side of the triangle, right? Which would be the height of this person. So like with this one, like I said, we're not going to solve it, but Derek's 6 feet tall approximately, and it says he's standing 3 feet away. So you guys can kind of see what is going on there. Oh, sorry. Recording this early in the morning. So now the other scenario, so now we have Derek, who is now gazing down longingly into Leilani's eyes. Okay? And so what is the angle of, it shouldn't say elevation, this should be, say, the angle of depression. From Derek to Leilani. So again, let's sketch this. So you got Derek standing up. And Leilani laying down. Okay. So the horizontal on this one's not quite as intuitive, because when you're standing up, are you normally just looking down or looking up? No. Your normal horizontal would just be looking straight out. So that's our horizontal from this one. And because it's an angle of, oh, come on, depression, that means we're gonna go from the horizontal and look down. Like it says that He's staring longingly into Leilani's eyes. And so now you guys can see where we get our angle, our theta. And then our other side of the triangle is still going to be right there, and that's just going to be whatever the height was. So Derek's height, again, we estimated was 6 feet, approximating that he's above the ground. And then they were 3 feet away. So still the same sort of triangles, but not 100%. So big thing here, if you have an angle of elevation, your picture is going to look something like this one. If you have an angle of depression, your picture is going to look something like that one. Okay? So, knowing that, let's do some real examples. So, I'm going to use my cheater tools. Okay, we got a tree. So this problem says the height of a tree is 15 meters to the nearest degree, aka whole number, what is the angle of elevation, so we're looking up, of the sun when the tree casts a shadow that's 9.3 meters long on ground level, okay? So we got our tree, and our tree is casting a shadow, okay? Our tree is 15 meters tall, and the shadow is 9.3 meters long, okay? Angle of elevation, so that means we're going from ground level and looking up. Ground level up. So that's where we get that triangle right there, and our angle of elevation is going to be this angle right here. So that's going to be our theta. And now we have our triangle set up, so we just do like what we've previously done. We have our opposite side, and then we have our adjacent, because we're assuming this is 90 degrees. Okay? And so, if we have opposite and adjacent, we have TOA, or tangent. So our tangent of theta would be 15 over 9.3, but we're solving for theta, so our theta would equal the inverse tangent of 15 over 9.3. Plug that into our calculator. Second tangent, or shift tangent, 15 divided by 9.3. And we're rounding to the nearest degree, right? So the nearest whole number, so our theta would equal 58 degrees. Okay? So sketching the picture here is going to be pretty important to help us out. Okay, one more, and then you guys are off to the races to work on whatever you need to work on. Most likely the homework, okay? So with this one here, a sonar operator on an anchored cruiser detects a pod of dolphins feeding at a depth of 255 meters, directly below his ship. If the cruiser travels 450 meters west and the dolphins remain at the same depth to feed, find our angle of depression, and we're going to represent that by x from the cruiser to the pod. Okay, so let's sketch our picture. You got our ship. Okay. From our ship, here's a pod of dolphins down, and they're at a depth of 255 meters. Okay? So assuming the cruiser unanchors and travels 450 meters west, so we got our other ship. And now this ship, where obviously they float on water, is to the west. And that one's 455 meters. Find the angle of depression, which would mean we're looking down. So we have a horizontal and we're looking down from the cruiser to the pod of dolphins. So we got from our cruiser to the pod of dolphins, so you can see where our triangle is being made. So we got our 90 degrees, our angle of depression, which we're going to represent by X this time, because that's what it says. For this problem, guys, it doesn't tell us what we need to round our answer to. So when it doesn't tell us what we need to round our answer to, just, I gotta thank Dylan Osmond for this one. When in doubt, 100 out. Okay? When in doubt, 100 out. So when in doubt, round to the 100th place. Okay? Gotta identify which trig ratio we're gonna use. So we got our opposite side and our adjacent, because it's not the hypotenuse. So we're going to use our inverse tangent again. So we're going to have x equals the inverse tangent, sorry guys, they're emptying the trash, of our opposite, which is 255 over 455. Plug that into our calculator. Second tangent, 255 divided by 455. Oh no, it's not 455, it's 450. Heh. Hopefully you guys caught that. Enter, and when in doubt, 100 out. So 29.54 degrees. Okay, that's a horrible box. There we go. All right. Okay, guys. So that's today's lesson. Please reach out if you have any questions, and best of luck.